we're going to look at something here that's known as a trigonometric integral because it involves a couple of trig functions. The way we handle these is through substitution, and what we'll do is we'll keep in mind our derivative formulas. For example, I know that the derivative of the sine of x is the cosine of x, so maybe I will use this. Now the problem is I've got cosine to the fifth, so I'd have to do something with the other four factors of the cosine. In order to do that, what we'll use is our favorite trigonometric identity, cosine squared of x plus the sine squared of x is equal to 1. With a little creative use of the substitution and the Pythagorean trig identity, we'll be able to evaluate this integral. What we're going to do in this case is we will actually use this derivative substitution. What we'll do here is we'll pull off a cosine of x, which will leave us with cosine to the fourth of x, sine to the fourth of x. The problem is if I let u be equal to the sine of x, I still have this cosine to the fourth of x until I use my trigonometric identity. What I'll do is recognize that cosine to the fourth can be written as cosine squared squared, and now I'll use the trigonometric identity cosine squared of x plus sine squared of x equals 1 by solving for the cosine squared of x. And there's our identity. And so we replace cosine squared of x by 1 minus sine squared of x. And now it's time for our substitution. We'll let u be equal to the sine of x, du will be equal to the cosine of x dx. So here is my du. The sine squared is going to become u squared. Sine to the fourth is going to become u to the fourth. So this becomes 1 minus u squared squared times u to the fourth du. Now this isn't a straightforward integral, but if we expand this out and then distribute u to the fourth through, there we've expanded it, and now we distribute u to the fourth through, it's a straightforward polynomial integral. So we now integrate. We'll get 1/5 u to the fifth minus 2/7 u to the seventh plus 1/9 u to the ninth, and then we resubstitute u is equal to the sine of x, and we have our answer. For a more advanced version, or for another example that is, of trigonometric integration, look at the video for trig substitution, which requires that as one of the final steps.